Sri Lankan-British astronomer, astrobiologist, co-proponent with the late Sir Fred Hoyle of the theory of cometary panspermia, Chandra Wickramasinghe is a pioneer of the new science of astrobiology. Chandra Wickramasinghe received his early education at Royal College, Colombo and the University of Ceylon. In 1961, he went to Cambridge in the UK, where he began his lifelong collaboration with Sir Fred Hoyle. Professor Wickramasinghe was a Fellow of Jesus College, Cambridge from 1963 to 1973. Professor at University College, Cardiff and Cardiff University from 1973 to 2011. Currently, he is an honorary professor at the University of Buckingham, UK. Professor Chandra Wickramasinghe, thank you very much for joining us.
Thank you.
Chandra, I want to start by asking you this question. Why is it we do not often hear about your groundbreaking studies on the cosmic origins of life?
Well, I think there's a long-standing kind of a silence that has come over this. The logical conclusion from my half a century of scientific work is that there is no question whatsoever that life did start on the Earth. It did not start on the Earth, for sure. And so this is the heresy, because the standard point of view that people have grown up with, every single textbook in biology tells you that life started in a primordial soup on the Earth and so on. So we've grown up with that, and scientists have puffed this theory up into a huge sort of almost an edifice that is now very difficult to break down. That's the problem, and the evidence is compelling at the moment for life not being of terrestrial origin. I think that comets brought life to Earth in the form of bacteria and viruses from the depths of space, and the continued introductions of life in this form of bacteria and viruses essentially led to the whole process of evolution that we see here on our planet, and the process that led eventually to ourselves coming into existence. But it's been resisted. I think there's a cultural taboo against any challenge of the standard point of view in relation to the earthbound theory of the origin of life. I hope this would eventually die down and that facts would be respected. But it's still a long way from that. In 2021, present day, the idea that life came from space, or life can be in any way connected with deep space, with the universe at large, is an absolute heresy. And irrespective of all the evidence that we've accumulated, is still regarded as heresy. So we are heretics, we who propagate this theory, who support this theory, are heretics, and we are treated in the way that heretics have always been treated. Or that is to say, as you said, why haven't you heard this? We are deliberately ignored. Sometimes, though not so often nowadays, we are persecuted as well. And I should tell you that I think your listeners would probably like to hear this story. The pre-Socratic philosopher Anaxagoras, who essentially was responsible for enunciating the panspermia theory that we have been all working on for many decades now. He also proposed that the sun was not a god, but a red-hot stone, and the moon was made of just a lump of earth. And for this heresy, he was essentially banished from Athens, from his native state. So that's the kind of punishment that heretics endured. And I suppose Anaxagoras' punishment is mild compared to Giordano Bruno, who in 1600 was burned to death for offending the papacy by saying that there are many planets with life on them and so on. And Well, this has gone on. This goes on, and it hasn't come as a surprise to me or to my collaborators who keep on working on what we regard as being the absolute facts of the universe.
Can you describe the first ideas and evidence that led you to conclude that the universe is teeming with life?
Yeah, well, I think 50 years ago, if you told me this, if Mike told me that the universe is teeming with life, that viruses were all out there and so on, I would also have shrunk in disbelief. It's not something that you take on lightly, and you need evidence to support that kind of point of view. And it took me and my long list of collaborators several decades and a long series of astronomical discoveries, astronomical observations, detailed analysis and calculations to reach this conclusion. So it was not by any means reached lightly. It came, in fact, in several steps, very discrete, definite steps. In 1976, which goes back a long time, we had evidence for large quantities of organic molecules, right? So these are combinations of carbon, nitrogen, hydrogen, and so on, assembled into long chains, which are called hydrocarbons, and also double ring molecules. This is way back in 1976. We accumulated this data from astronomy and published it in Nature and so on. And these were disputed in some circles, but they were also praised as being a major breakthrough in the chemistry of interstellar space. In fact, we had molecules that resembled, or we claimed at that time to identify molecules that resembled chlorophyll, the light-gathering molecule that is very crucial for life on the Earth. So all these molecules were there, and double ring molecules, such as occur in DNA, we found evidence for that. So this was what was happening in 1976, and gradually cosmic biology was beginning to look more and more plausible. Life molecules, at least, the molecules, components of life, were found everywhere in the cosmos, in the deepest recesses of the cosmos. Then what we did for the next 4 or 5 years was to study the way in which cosmic dust, and cosmic dust is what you see in the dark patches between stars in the Milky Way. If you look at the Milky Way on a dark night, you see sort of band of stars stretching from horizon to horizon, and in between that band of stars, you see huge shapes of dark striations, elephants' trunks, and resembling elephants' trunks and so on. So these are dense clouds of cosmic dust. So astronomers for several decades, up to 1970, were struggling to understand what these dust clouds were made of. What is the dust that fills cosmic space so profusely? Now, what we did in between 1976 and 1982 was to do a lot of astronomical observations. We collected lots of astronomical data. We did lots of calculations. And we came to a rather startling conclusion that the dust that you see in the dark clouds of space is comprised of two populations of organic particles. The first population has sizes, individual particles has sizes exactly the same as the sizes of bacteria. And the second was also organic particles that had to possess sizes of viruses, nanometer sizes. So this is the situation that we were facing in the late 1970s. Then in 1982, we had a really startling breakthrough. We said that if these particles in space, in deep space, and they were not a trivial amount of material there, the material in the form of the dust in space amounts to about 1/10 of all the matter in the entire galaxy. So it's a significant proportion of the mass of our galaxy is made up of these dust particles that, as I said, we inferred had sizes of bacteria and viruses, two different populations. Now, in 1982, we conducted an experiment in the laboratory to get an absorption profile in the infrared. This is in the deep red, further than the red, in wavelength, longer than red wavelength, of bacteria as they would be in interstellar space. We had this as a sort of a profile, a pattern that we had to look for in astronomical data to see whether this particular pattern was reproduced in astronomy. Now, when we made this experiment in the laboratory, my colleagues and a student named Al Mufti, who did the experiment, we approached many observatories around the world and asked if they could look at the deepest sources of infrared light in the galaxy and see whether this pattern of bacterial material is there or not. And very few people decided to take this seriously, but as it happened, I had a younger brother who was professor of mathematics at the Australian National University. His name is Dial. And he and a colleague, David Allen, used the then most powerful telescope in the world, which is the Anglo-Australian telescope, to do this observation, astronomical observation, to look for the signature of bacterial dust that we had predicted. So the weeks went by, and we were waiting for the result, and suddenly Dahl sends us a fax to UK, to Cardiff, with a spectrum that matched precisely the spectrum of the laboratory sample of bacteria. So here you have a prediction, a definite prediction, which we made, and then you have an astronomical observation that matched absolutely precisely, point by point it matched. So this we were dumbfounded by this, and we published it, and then we had lots of responses. Of course, there was skepticism because, as I said earlier, life in space is still a heresy. So they had to wriggle out of this and say, maybe the stuff there looks like bacteria, but they're not bacteria. They're just mixtures of the components of bacteria, the molecular components of bacteria. So it went on and on like that. 1976, another really interesting development took place. Halley's Comet, which is a very famous comet, returned to perihelion, to be close to the sun. It's a comet that has a period of 86 years. So it came in 1976, and this was in the space age. The European Space Agency had a mission to examine it at close quarters. So it had a spacecraft that essentially flew by it. And so a lot of data was gathered from that encounter, from the Halley Comet encounter of 1976. And again, we had predicted that if there were bacteria, then there would be certain patterns to be seen. And exactly those patterns were seen. The predicted patterns of bacteria were found in the tail of Halley's Comet. And this again was, the observation of that was involved my brother in Australia and a lot of other people as well. So it was, this was absolute shock to us as well as to other people. But all of these things didn't have much of an impact on the very hardened establishment of science that had said there can be no life outside. So these had to be life-like material produced somehow to mimic the properties of biology. So this went on, and it kept on right through the decades. We had a long series of predictions that we made of the life from space model. We proposed comets as being the amplifiers, the distributors of life through the cosmos. We made very many predictions. Every single prediction over the past 4 decades has been verified. So this is where we are now. We have a theory that has been amply verified. Predictions have been verified, but still there's a very strong resistance to accepting it as hard fact.
What are the implications of your fundamental findings?
Well, I think the whole of life has to be regarded as being a cosmic phenomenon. Life could not have arisen on the Earth except for the deep cosmos providing the complex arrangements of molecules that make up life. The probability of primordial soup that people are talking about, producing anything like a bacterium, anything like DNA or the amino acids needed for a bacterium to function, the probability is absolutely minuscule, zero, precisely zero. And it is this improbability that we've been stressing for nearly 3 or 4 decades now, and it is not still registering with the mainstream astronomers. They are still continuing to try to mimic in the laboratory the process by which life might have started from non-life in a terrestrial organic soup on the Earth. And it's been a dismal failure for nearly 40, 50 years. So that's where we are. And the evidence that is mounting also from geology. We know that the oldest evidence for life on Earth dates back to something like 4.2 billion years ago. And this was a time when we know for certain that the Earth was being pounded by comet impacts. There couldn't have been a quiescent period during that epoch it's called the Hadean epoch, the epoch of hell on the Earth. And it's in rocks that formed at that time that you have the oldest evidence of biology on our planet. So comets certainly seem to have brought the first life onto the Earth, and the continuing injection of bacteria and viruses, I should say, over the next 4.2 billion years is what gives the whole panorama of life that we have here on our planet. If not for that, life would not have evolved even up to the stage of a single cell, and certainly not beyond the stage of a single cell. It needed the whole universe to cooperatively produce the information that is needed for the first life and for all of evolution. And this is dispersed now. The components of the evolutionary process are dispersed, I think, in the form of viruses right through interstellar space, right through the universe.
Bill Gates was asked probably 2 weeks ago if he was concerned the origins of COVID-19. He said, no, I'm not. Shari Markson in Australia said it came from Wuhan, from a lab leak. Chinese, they were very naughty. We have all sorts of theories floating around. The origins of COVID-19, why is it so important to know?
I think it's part of the story of life on Earth. My conviction is that viral pandemics in human beings are caused by viruses and have continued to cause pandemics right through our history. We have a lot of epidemics that are well documented in historical record. We have the plague of Athens, for instance, the plague of Justinian, and most recently the Spanish flu. And I think all of the evidence, certainly in relation to the Spanish flu, which is in 1918, 1919, there is absolutely no possibility that this was a virus that came essentially on the Earth, came from China or wherever, and then spread around the Earth. Every bit of evidence that is documented shows that there was a component of this virus that was being essentially carried around in the global weather system and fell wherever conditions, local conditions were appropriate. For instance, it's been stated, recorded, quite carefully recorded and accurately recorded, that the first outbreaks of the lethal second wave of this 1918-1919 Spanish flu pandemic occurred in Boston and Bombay on the same day. In 1918, there was no air travel. There was no way in which humans could have transmitted the virus from Boston to Bombay or Bombay to Boston. So this is clear evidence that that the virus was deposited from the sky. In our own experience, I should maybe recall a very, very significant event that happened in the course of our studies of cosmic life. In 1977, there was an influenza pandemic that was called the red flu pandemic. It was caused by a subtype of the influenza virus known as H1N1. And that virus was not around on the Earth for 30-odd years. It was unknown on the Earth. There was no possibility that school kids, for instance, school children would have been exposed to this virus in their lifetime. So Fred Hoyle and I thought this was an ideal opportunity to regard the school children as detectors of this new H1N1 pandemic virus. And we went to all of the schools, the boarding schools and the public schools in England and Wales, and collected an enormous amount of data on the timing of the attacks on different schools, on the timing of attacks in various houses of schools. Because, for example, in some of the posh schools in England, Eton, they have many boarding houses, and the boys are divided into these houses. And so we were able to determine how many cases, how many children, boys went down with influenza, when they went down with influenza in the different houses. And all of this data we were able to analyze and show quite convincingly that person-to-person spread, although it happened, was not the major process by which this influenza spread amongst the susceptible detectors, as we like to think of them, the children, school children. And so this was a strong indication that there was a component of person-to-person infection, but an overwhelming process that dominated the whole pandemic was just higgledy-piggledy infall of the virus from the sky and from the atmosphere. And so this was the start of our confidence on the whole theory of viruses being transported in the global weather system and falling onto the Earth in a sort of very patchy way. And that's what's happened in the case of the COVID-19 as well, I think. I mean, there's no question that COVID-19 is infectious. It's an infective agent, so it can pass from one person to another, and that has surely happened. But in order to explain all of the data, Professor Steele and myself and a whole lot of colleagues have examined the totality of data available on the COVID-19 pandemic, and we conclude that a major effect is the infall, the continuing infall from the global weather system of a virus that was introduced almost certainly, I think, into the global weather system from outside. And we have tentatively identified a meteor event in China in 2019, I think it was, that could have triggered this. So this is the story, and I think just quite apart from the present pandemic, I think the whole history of human civilization over thousands of years have been punctuated by a long series of pandemics, a long series of meteor strikes as well, meteorite strikes and pandemics. The rise and fall of empires, I believe, has been more to do with this natural sequence of events, with the recurrence of pandemics, than with the misdemeanors of rulers and tyrants. Well, that's certainly my point of view.
Why do many?
I should also say that this is for viruses in our immediate vicinity, viruses that cause diseases like influenza and COVID and so on. But since the human genome was fully sequenced in the year 2000, we also know now for absolute certain that our DNA and the DNA of all our sort of primate relations, as it were, evolutionary relations, it's plattered with the residues of viruses, right? There's retroviruses that Ted Steele has been working on and other people have been working on. And these are all over the place in our DNA. In fact, most of our DNA is nothing to do with our existence, nothing to do with useful things that the DNA is doing, but with dead DNA. And these resulted, these inserts, the retroviral inserts, herbs and so on, resulted almost certainly from past pandemics. And with DNA sequencing of our primate ancestors, it is also becoming clear that right through our evolution, not just through our history of thousands of years, but through our entire evolutionary history of a few million years as primates, there have been a long series of viral pandemics, and these have left their mark on the DNA of creatures that exist at the moment on the Earth in different forms.
Why do many pandemics of the type we see with, say, COVID-19 seem to begin first in China?
I think that is very easy to understand. China is eastwards of the highest mountain range in the world, which is the Himalayas. The Himalayas essentially punctures a hole in the troposphere, and all of the weather patterns around that area is controlled by this event of Himalayas puncturing a hole in the troposphere. So anything that is brought in from the stratosphere into the troposphere tends to be carried first into the plains of China. That's the way that the weather system works. So I think there's no difficulty, as far as I am concerned, to understand why the first strikes of many of these viruses, like influenza, all the new subtypes of influenza seem to come from China. It's not because the Chinese live in close proximity to animals, which is the standard story. It's because of the Himalayas puncturing a hole, and it's because that many of these viruses have an extraterrestrial origin. They come from comets, they are deposited into the troposphere, into the global weather systems, and they are carried in first in the winds into China.
What's your assessment of the scientific progress in your lifetime as a scientist?
Well, I think the progress has been enormous. And when I grew up in nearly 7 decades or 8 decades ago, there were no jet aircraft, there were no communication satellites, and so on. So all of these have happened in the last 8 decades. So technical advancement at that kind of level has happened at a tremendous rate. And then there's genetic space exploration has progressed enormously. Genetic engineering has progressed, biotechnology, medical science, the average life expectancy of humans has gone up significantly. And of course, most importantly, the way that we are now communicating across this, from the UK to Australia at the moment, is due to the internet and to computers. And so the advancements in things like that have been really tremendous. I think the next decades we'll see more progress of a similar kind. There will be more sophisticated computers, there would be better biotechnology and so on. But unless the paradigm shift that is being halted is essentially completed, the paradigm shift from Earth-centered life to cosmic-centered life, I think we would be there would be a stalemate in progress in relation to a lot of disciplines within biology and within astronomy as well, within astrobiology. I think the fact that the ideas of life from space is being resisted is partly due to innate conservatism. Human beings don't like to change their mind. They don't like to change their houses even. It's all very traumatic if we have to move house or to move country at any stage in our life. So there is an innate conservatism in humans that is preventing us from changing from the Earth-centered to the cosmic-centered viewpoint. But more importantly, in my view, is that the cosmic theory of life has been identified as something that is alien to Eurocentric culture, to Western culture, to Christendom even. And that has been a silent obstacle to the process of accepting facts for what they are. And as I said, the number of predictions that have been made on the basis of the cosmic theory of life that have been fulfilled, that have been verified, is growing ever larger, and yet the resistance still persists. I think this is part of innate conservatism. It's part of also an imperial instinct. I think the instinct that science in the Western tradition developed in a Eurocentric culture, in the age of the Enlightenment, and I think, well, in my view, decolonization of science is a process that is long overdue, and that is one of the effects, the sort of identification of the idea of life being cosmic as being an alien concept, alien to Eurocentric culture. This has to be overcome.
In this day and age of COVID-19 and the hysteria that surrounds it, science seems to have been thrown by the wayside, and there is only one narrative. So, I mean, just recently, even YouTube took off anything that said anything bad or anything that was contrary to the narrative about the vaccine. So that discussion is almost gone. So
well, I think censorship is really very strong, and that has to be overcome. I think there's no science that could proceed sensibly with such strong cultural obstacles, strong censorship to ideas that are not acceptable. I mean, the idea that the virus was, this current COVID-19 virus came from animals is just laughable, because if you work out the probabilities of the bat virus going through pangolin and achieving the kind of the number of mutations that are needed to reach the human variety of this virus, it is just impossible to have happened in all the time that's available in the universe. So I think one should really reject that absolutely. The other possibility that's that's being aired is that it's an artificial virus, and I don't really go for that in very enthusiastic terms. I think there is also one has to realize that we have the technology to do dreadful things now, and that we have groups of people who are sufficiently minded, if you like to put it that way, to do things that are to society, to humans, that are almost suicidal. This is not absolutely impossible. But I think as far as the origin of the COVID virus is concerned, it is part of a natural process that has gone on for thousands of years. And why invoke any other process than is involved in these other earlier viruses? I think the most natural explanation to go for and to explore scientifically is the idea that the virus came from space, like all other viruses did, and all other viruses that contributed to our evolution. We've got to remember that if not for viruses, we would not have evolved beyond this level of a single microbe. So viruses are bad for us in a sense, but they're also crucial for the evolution of life.
I was talking to a friend of mine in Utah, in Park City, about life and the start of life, and I said I was going to be talking with you later on in the day, and he said, "Look, I would love to know what your thoughts are on the beginning of life, because we talked about all these different theories as much as we could, because one is an accountant or a CPA, and I'm me, so I have limited knowledge on these things. But you always, nice discussion over a glass of red if possible. We went right back to the start. I said, look, he said maybe it was a big bang, maybe it was that, maybe it was that. And I said to him, but what started that? So the question I pose is, how could something start from nothing? And does that leave open, because you're a scientist, so from your point of view, does it leave open that there is a God or there is not a God? And then that itself makes it hard to understand, because it reminds me of a story I was taught at school, that the boy was sitting on the beach digging a hole, and he's just putting water in, and this philosopher walked past him and said, "What are you doing?" And the boy said, "I'm trying to put the ocean into this hole." And the philosopher at this stage is trying to work out the start of life, what it was all about. And the philosopher said, "But you can't put in all the ocean into that hole because there's too much; it won't fit." And the boy replied, "It's the same thing you're trying to do." So, can I ask you, is there, from the very beginning of life, the molecule, what started the molecule?
I think all of the basic processes of physics, all of the basic components of physics, all of the basic components that make up life, they have always been there. That would be my personal belief. I don't have any science to back it up at the moment, but I mean, the current fashion is to say that the whole universe began with a single Big Bang 13.8 billion years ago. Now, there's no question that there was an event of which we are the inheritors 13.8 billion years ago later. If you take the material of all our galaxies and so on, and the way that they're moving away at the moment, I mean, this universe seems to be expanding at an ever-increasing rate. So there is a beginning of the material that you see around us. But was that the absolute beginning? Was there a real, definite beginning of the universe? This is a question that is still up for grabs. There are astronomical observations that have come in the last 2 or 3 years that are presenting a very serious challenge. We are finding galaxies at maybe a few 100,000 years after the so-called Big Bang origin of the universe. They should not be there, and they are there. Nevertheless, there's no question that they are there, and this has raised many questions. Was the Big Bang just part of a whole sequence of similar events that that continued forever or would continue forever? And scientists like Roger Penrose, Nobel laureate Roger Penrose, has posed this question: was there a sequence? Is it an oscillating universe that goes from bang to crunch to bang and so on? And so this is still an open question. I would like to think of a universe that has no beginning and no end, and the Big Bang was just one local event. And if you ask when the process of life started, I think that life and the components of matter, or the fundamental particles, the laws of physics and so on, were always there. They are part of an infinite, eternal universe. This is a personal point of view. There's no hard evidence that I can say to support it, but there is a growing body of evidence that says that the Big Bang is not the last word on the beginnings of the universe or the beginnings of life within it. I mean, if you go back to in history, or a few thousand years ago, it was quite a different story, isn't it? I mean, there was a theory of the universe where it was considered to be a huge globe carried on the back of a white elephant, the white elephant riding on a tortoise, the tortoise swimming in a sea, and so on. And all of these have been suggested by not by scientists, but by thinkers, by poets, by philosophers, and so on.
Maybe we've been indoctrinated or taught. It's very hard for us to imagine there's no beginning, that there was a beginning and the end, because we all start and finish. We all believe that. But to think about something not having a beginning and most likely not having an end, it's a very hard thing to comprehend, isn't it?
It's a very hard thing to comprehend. And in fact, it's I found it easier to deal with that because I come from a Buddhist background, and Buddhism was it's essentially acknowledged to be the philosophy or the religion that introduced the concept of infinity, right? So something going on forever is something that is really natural to an Eastern way of thinking, to a Westerner, where in a Judeo-Christian tradition, this is alien. And so this is another problem that one has to face. Cultural objections, cultural resistance to ideas that have been deeply ingrained in certain cultures. For instance, in the Judeo-Christian culture, the creation is a discrete event. There was a God, there was a creation, and so on. So that creation was supposed to be centered on the earth, but now we have moved away from that with the advancements in science, and we think the creation was the creation of the universe, a Big Bang maybe. But is that the last word? I think not. I think the whole situation of the origin of life, the origin of the universe is still up for grabs. I don't think we have definite answers. But what we know for sure is that our existence of life on Earth, is intimately connected with the universe at large. If not for life being distributed in the form of bacteria and viruses throughout the galaxy, throughout the cosmos, we would not be here. That I am absolutely certain of, and I think that is a paradigm shift that has to happen if we're going to make further progress in biology, further progress in science. To resist that is just absolutely crazy, and it would hinder the further development of science.
Do you still have, I mean, this is just, this is a wonderful conversation. Do you still have, going right back to when you started or when you wanted to be a scientist to now, do you still have that, I suppose, fire in the belly still?
Yeah, I still like to know where we came from and how did it all happen. I think I have, over decades. I've lived for 8 decades now, and over the last 5 decades of active science, I think I've come closer to answering some of these questions, but I would like to know more. I think there's always more to learn, there's more more questions to ask, and so I keep on going, and I find that this is going to be the case for generations to come. There will be no final answer to many of these questions. I think that is all the better for the progress of science. We need to go forward with new questions to answer.
As we wind this conversation up, the health of science at the moment, with all, we have theories on climate change, or whether it's a theory or just a narrative, which is different, whether we have the theory or the narrative on COVID, just on all sorts of things, and it seems to be the health of science is waning somewhat.
I think so. I think it's waning partly because of the impact of big money. In the old days, a philosopher, a scientist could do his thing in isolation or in a small group, and he didn't require huge funds, huge resources to do his job. But now, to succeed in any scientific venture, you need maybe big teams of scientists, and you often need very expensive equipment. And if that is not accessible to individuals, I think it's not accessible. We don't have people who are rich enough to own accelerators or to have machines to decipher or decode DNA. We need societal support. And that's where the problem arises. The censorship that is enforced on a group of people who are wanting to make progress, unless they conform to some existing paradigm, that is a serious problem for the future progress of science. We need an independence of thought, independence of action, and innovation to go ahead, independent of all the constraints of powerful bodies, of academia, academies, and the financial constraints are very serious for big science, and that's going to be a problem.
Professor Chandra Wickramasinghe, thank you very much, truly, and it's a totally enjoyable conversation. Thank you, sir.
Thank you.